In this video, I'm going to go over the answers to the first quiz. You should, if you did not get a great grade on the first quiz, you should go over these answers. On the other hand, if you did well, then you can just briefly look at this just to confirm what you already know. So the first is to find the pH, pOH, and the hydroxide ion concentration given these various hydrogen ion concentrations. And the first one here is 1.78 times 10 to the minus 5. Now the easiest thing to do starting out is to find the pH for this. And the pH is going to equal the negative log of this number, 1.78 times 10 to the minus 5. And so if you get your calculator out and you put 1.75 enter exponent to the minus 5 and hit log base 10, you get minus 4.74, actually 4.75, three significant figures, and then the negative of that is going to be 4.75. So that's the pH. The pOH, the easiest way to calculate the pOH in this situation is to realize that pH plus pOH has to equal 14 because the concentration of the hydrogen ions plus times the concentration of the OH ions has to equal 1.0 times 10 to the minus 14. So if you remember that, then you can just subtract this number from 14 and you'll get the pOH is 9.25. Now the other way to do this, if you don't want to do it the easy way, is you can take this number, you can put in 1.78 times 10 to the minus 5 and solve for the OH concentration times 10 to the minus 14. And if you take 1 enter exponent times 10 to the minus 14 and divide that by 1.78 times 10 to the minus 5, you get the OH ion concentration, which is 5.62 times 10 to the minus, it's going to be by times 10 to the minus 10. And then you can put that in here, take the log base 10 of that, and you get the same 9.25. And then you have this answer. So you can either go from here and get this by subtracting 4.75 from 14 and then do it this way, or you can do this and put this in and you get this first and then you take the negative log to the base 10. So just to show you how you do this, to get the OH concentration from the pOH, you take 10 and it's going to be minus, don't forget the minus sign, 0.92. Then in your calculator, you put that number in, minus 9.25, and you raise 10 to that power, 9.25, and you raise 10 to that power, and you get this same number right here. So the answers here are 4.75, 9.25 for the pOH, and then 5.62 times 10 to the minus 10 for the hydroxide ion concentration. Now, doing the next one, if the hydrogen ion concentration is 2.21 times 10 to the minus 9, again, you put the pH is going to be the negative log of that number, 2.21 times 10 to the minus 9. And if you work that in your calculator, you get 8.66. Then the POH is going to be 14 minus 8.66, which is equal to 5.34. Then the hydroxide ion concentration is going to be 10 raised to the negative 5.34, which is going to equal 4.52 times 10 to the minus 6. Moving down here, just realize that we're not talking about hydrogen ion concentrations anymore. We're talking about hydroxide ion concentrations. And so the hydroxide ion concentration is given at 5.19 times 10 to the minus 3. Because this is the hydroxide ion concentration, you're going to be calculating the POH as the negative log of that, 5.19 times 10 to the minus 3. And if you do that, you should get 2.28. The pH now, you already found the POH. The pH now is going to be 14 minus 2.28, which is going to equal 11.72. And then the hydrogen ion concentration is going to be equal to 10 raised to the negative 11.72, which is going to be 1.93 times 10 to the minus 12. The last one here, the hydroxide ion concentration is 3.91 times 10 to the minus 11. So the POH is equal to the negative log to the base 10, just to make sure you don't forget that, of 3.91 times 10 to the minus 11, which is going to equal 10.4. And then the pH is equal to 14 minus 10.4, which is equal to 3.6. And then the hydrogen ion concentration is going to equal 10 raised to the negative 3.6 power, 3.59 actually, because this was a 1 here. Keep the significant figures right. And you get 2.56 times 10 to the minus 4. So there's those 4. There'll be something like this on the test, so make sure you understand how to do this. This last section, just make sure you understand the definitions of acids and bases. So let's go through these. First of all, we have the NH2 minus plus C2H2 goes to form NH3 plus C2H minus. Now, the way you determine, this is a 2 here, the way you determine this is to see who is an acid. Remember that an acid is a proton donor, which means it gives up a hydrogen. And a base is a proton acceptor, which means it gains a hydrogen. Proton acceptor. That's the Bronsted-Lowry definition of an acid and a base. And so, if you look here, this gains a hydrogen going from here to here. So this has to be the base. And this loses a hydrogen, so it donates a hydrogen, so this is the acid. And then going the other direction, going from right to left, this loses, so it is the conjugate acid. And this gains a hydrogen, so this is the conjugate base. So as this one goes back this direction, it's gaining a hydrogen, so it has to be a base. And all the rest of these are the same way. If you have H3CO, H2CO3 plus OH minus goes to form H2O plus HCO3. Going in this direction, this species loses a hydrogen. It donates a hydrogen, so it's the acid. This one gains a hydrogen, so it's the base, it's the proton acceptor. And then going back in the other direction, when we go this way, this loses a hydrogen, so this is the conjugate acid. And this one, as it goes from here back to here, it gains, so it's the conjugate base. The last two, this one, pH, which just means phenol, but you don't need to know that yet, plus Cl minus goes to form pH COO minus plus HCl. Now, a little trick here, this can't lose a hydrogen because there ain't no hydrogen. So this has to accept a hydrogen even without looking at it, although when you look at it, it obviously does. And so this has to be the base, which means this has to be the acid, and indeed it does lose a hydrogen going in that direction, so it's the acid. Coming back this way, this gains a hydrogen, so it's the conjugate base, and this loses a hydrogen going this way, so it's the conjugate acid. Lastly, we have CH3 times 3 OH plus NH3 goes to form CH3 3O minus plus NH4 plus. If we look at this, this loses a hydrogen, so it's an acid. This gains a hydrogen, so it's a base. Going back in the opposite direction, when this goes back to here, it loses a hydrogen, so it's the conjugate acid. And this going back this way gains a hydrogen, so it's the conjugate base.